Please make sure you have viewed simplifying rational expressions, multiplying and dividing rational expressions, adding and subtracting rational expressions before viewing this video. So today we're going to work on simplifying complex fractions, and its name implies exactly what it is. They're fractions that are kind of all over the place. They're very difficult looking fractions, and simply put, it's fractions over fractions. Here's an example of a complex fraction. Yeah, that looks pretty complex to me. So the point of complex fractions is to treat the numerator and the denominator as separate questions. Treat this as three questions in one. An addition or subtraction question, an addition or subtraction question, and finally a division question. So that's exactly how we're going to set this up. Whenever you have fractions over fractions, I'm going to separate the numerator with a set of parentheses, and then that fraction line just means divide, and I'm going to separate the denominator with parentheses. So let's clean up in the parentheses first. This denominator is 3, this denominator is x, so my common denominator is going to be 3x. So let's multiply this fraction by x over x, and this fraction by 3 over 3. Okay, so let's clean that up. We have x squared over 3x minus 9 over 3x, all being divided by x minus 3 over x. Once you have a common denominator, write it once and read right across the numerator, x squared minus 9 divided by, and I could drop this parentheses now because we already have a common denominator. And now we have a division question. Keep, change, flip. Now I'm going to factor the x squared minus 9 right away. Change the multiplication and flip the second fraction. So now we can look for things to cancel. We can cancel an x minus 3. We can cancel an x, leaving us x plus 3 over 3. Okay, so all we did, we made this vertical division into a horizontal division. We cleaned up inside the parentheses to get one denominator. Over here we already did. Then you have a plain old division question. Factor completely. Cancel. Simplify. Another example. 1 over 2d minus 4 over d. And that's all over 1 over d plus 3 over 2d. So let's express this as a horizontal division question. 1/2 minus 4 over d divided by 1 over d plus 3 over 2d. This looks a little more manageable. It's not as complex, at least. So now this denominator is 2, this denominator is d, so my common denominator is 2d. So that needs a d, and that needs a 2. D times 1 is d. 4 times 2 is 8. And now we'll come over to this side. This denominator is d. This denominator is 2d. So they both have d's, but this one's missing a 2. So multiply by 2 over 2. 2 times 1 is 2. That was already a 3. Oh. Now I'm messing up. Plus 3 over 2d. So now they have a common denominator. I can write it once. D minus 8 over 2D times, my common denominator would be 2D. You know what? I'm going to keep it as division for now. 2 plus 3 is 5 over 2D. I kept it as division just to show you that there's only one 2D down here. So when we flip it, there's one up there. I feel like if I would have done it preemptively, I would have had two 2Ds up there. So D minus 8 over 2D times, keep, change, flip, 2D over 5. Cancel the 2Ds, leaving me with D minus 8 over 5. One last example. Three over x squared plus 1 over x over 1 minus 9 over x squared. Let's separate the numerator and the denominator. Divided by 1 minus 9 over x squared. All I did was make that fraction line a division sign. So now let's clean up inside the parentheses. This denominator is x squared, this denominator is x. So this one just needs another x to get a common denominator of x squared. Then we're just going to read right across the numerator. X times 1 is x, 3 plus x. Divided by, well, this denominator is 1, even if it's not written. This denominator is x squared, so this one needs an x squared. So multiply the numerator and the denominator by x squared. So our common denominator is now x squared. Let's read right across the numerator. X squared times 1 is x squared minus 9. Keep, change, flip. And I'm going to factor that within the same step. X plus 3x minus 3. So we have a 3 plus x. That, you may think, cancels to a negative 1. But 3 plus x and x plus 3 are identical because addition is commutative. If this were 3 minus x, then I'd cancel it with this for a negative 1. But 3 plus x and x plus 3 are the same. But if you were thinking negative, your head's in the right place. But 3 minus x and x minus 3 cancel to a negative. Cancel your x squareds. Now there's nothing left in the numerator. That means 1. And there's an x minus 3 left in the denominator.